Hello world, it's me. When we left off in the last video, we were looking at these 5 Prolog cards, and we were about to play the game of one of these things is not like the others. In this video, we'll take up the collaborative effort between Mostek and Prolog in the development of this historic bus. And to answer the question of the game, this is the STD card out of all of these 5. I think by the time that the story is over, you'll see that this is being similar to the bacon and egg breakfast where the chicken is interested, but the pig is really committed to the project. So back to the beginning and the summer of 1978, when Greece was the word, I have a few email exchanges with someone that was intimately involved at Mostek and the development of their first STD boards. And they mentioned that the idea for a cooperative development of an open architecture bus was presented by Mostek marketing individual, and then once approved, the idea was taken to Prolog, and the rest is history. And I have no reason to doubt that version of the story. So in this video, let's go on and look to see what Prolog and Mostek were doing before they collaborated on this STD bus development in '78. And I think that'll give some insight as to where each of the companies were and how things panned out. It's actually an interesting story, just how things happened and evolved. So Mostek was founded in 1969, and before 1978, Mostek, of course, was known originally for making the Z80 along with their own product lines for memory and shift registers. And also by 1978, Mostek was starting to dabble in board-based hardware and development systems. They had a big board, multi-bus sort of card topology used in their own development platform. So while Mostek had recently entered the board market, STD was a far cry from anything that Mostek was offering at the time. Now Prolog, on the other hand, they were also started a little after Mostek. They were started in 1972, I think, but they were almost exclusively in the board market. In the early 70s, Prolog was making the PLS 400 and the 4000 series cards, which were based on the 4-bit Intel 4004 and 4040. PLS stood for Programmed Logic Systems, which was Prolog's interesting attempt to kind of softly introduce microprocessors without making them seem, too overwhelming or complicated with their first introduction. If you're looking for documentation and identifying cards, the Prolog PLS product line notation it's somewhat confusing. Some, like the PLS 401, were single board computers having RAM, ROM, and I/O, while others, like the PLS 403, was actually a set of boards that included the 4004-based 4111 CPU card, the 4112 EEPROM board, and the 4113 I/O board. So if you ordered a PLS 403, you got those 3 boards. The PLS 403 isn't just one card, it's a set of cards. And Intel always claimed to have invented the single board computer with a multibus ISBC 8010. Prolog actually had the PLS 401 long before the 8010 came into existence. These are some of the Prolog 4000 series, and you can see they've got edge connectors, so that part wasn't new to Prolog. But at this time, you can see that even on an I/O card, so this is an I/O card, the only connector is on this edge. There's no connector on the side opposite the backplane. And that's because there wasn't really a backplane in these cards. These weren't fully bused. What you would do is you would have wire wrap systems. So this would go into a rack, like a Vector rack or Prolog rack or whoever's rack. You would have these either wire wrapped, or you would have little eyelets back here, and you would do a point-to-point wiring between the eyelets. But basically, these cards were configured so that the backplane or the bus or the communication between these cards was on a ad hoc basis. So you would have these cards in a backplane, as I said, and that backplane would look just like this is a Prolog backplane. It would look just like this, but it wouldn't have this board mounted in back. You would just have these headers mounted in the back instead of a motherboard. So you had this short bus where you would have the address and the data and whatever control lines you needed going between the boards. So this is a 4112-2 EEPROM expansion and a 4113 TTL-IO. So you can see that, especially on the 4113, as I mentioned, there's no connector on this end. Everything came off of the connector down here, went through the TTL I/O, and then went back to the connector. From there, you would then wire it to the next card. So for example, this is a multiplexer. You may wire it to a multiplexer, or you may wire it to a driver that had, high voltage or high current drivers. But you basically would wire them, using, as I said, either wire wrap or the point-to-point with the little eyelets, from your processor card to your memory card to your I/O card, and then from your I/O card to your multiplexer, and then from your multiplexer to whatever signal conditioning you needed. Now you could, when you ordered a system, you could order a pre-wired card cage that were available for a specific collection of cards. So if you ordered the PLS 403, you would get the 3 cards, and you could get the backplane that was pre-wired for that. But you can pretty much assume that once installed, there were no 2 systems in the field that were identical. And no matter how much Prolog tried to simplify the concept, this must have been a nightmare to implement, maintain, and support. I mean, can you imagine somebody calling you up when their system doesn't work, and they wired the backplane, and they're just saying the system doesn't start. They didn't have any proper diagnostics, and it wasn't the same as any other system in the field. So that must have been an absolute nightmare to support. Now, after the 400 and the 4000 series, Prolog made the same type of a system with 8000, and this was based on 8-bit processors like the PLS, or like the 8008, the 8080, the 8085, the 6800, and the Z80. Just like on the 4000 series, the 8000 series had the PLS, which were kind of single board computers all in one. They also had the full 8000, rather than the 800. The 8000 series, which didn't have things like the I/O or memory. They were more of just a processor, and then you would have a different card that was just for memory and a different card that was just for I/O. In 1978, the Prolog catalog was still saying that the odds are better than 20 to 1 that a 4-bit system will do your job with capacity to spare. But of the 4-bit systems, by then Prolog was pushing the 4040 over the 4004. And if you look at the price list in 1978, a nicely equipped 4004 single board computer like the Prolog 4111 would run $140. The 4040 version was quite a bit more at $205. And the 8080 PLS 881 was way up at $260, which was nearly twice the cost of a 4004 version. So looking back, who doesn't wish that they didn't buy a truckload of the 4004 4111s now, that they could be hawking on eBay? In addition to these boards, Prolog was probably better known for their Series 90 programmers. So this is a Series 90 programmer. They then later came out with the M980. But this was their bread and butter core product line for more than a decade, and very much a cash cow for Prolog. In the end, according to a publication by Ed Lee, one of the Prolog founders and the CEO, it was the discontinuation of programmers and the loss of that cash income that really accelerated Prolog's demise in the end. But no matter what happened, Prolog will always be recognized as playing a pivotal role in microprocessor training and implementation. They introduced the microprocessor to thousands of engineers. They were simply one of the most advanced and early developers of microprocessor systems. As an aside, Ed Lee's publication, The Handbook of Channel Marketing, has a few good tidbits about Prolog, but it's a good read for anyone involved in sales and marketing. He's formalized lots of thoughts about his experience in small business marketing, and to me at least, many of his comments and insights rang very, very true. Physically, all of the Prolog boards we've been talking about, like the PLS and both the 4000 and the 8000 series cards, all have the same physical form factor. They're 4.5 inches by 6.5 inches. The 4.5 inches is required because that slid into a card cage. The 6.5 inches could be longer if you needed that extra space. But typically 4.5 by 6.5 inches. 56 fingers, on half on each side, and the fingers are on 1/8-inch centers. So that basic design went back to the original Prolog back in the very early and middle 70s. The 4000 series have +5 and -10 power supplies. The 8000 series then included 12 volts and had -5 or -10 depending on the processor and the memory chips, as well as any voltage requirements for special add-on cards like serial ports where you needed plus and minus 10 or plus and minus 12, digital analog controllers, and so forth. Despite pushing 4-bit processors, by 1978, 4-bit was wearing pretty thin. The 4004 was scheduled to be discontinued in a few years in 1981, and the Z80 and the 8085 were going full steam. So Prolog needed to phase out their 4-bit and update their product line to at least 8-bit. So something like the STD bus was actually long overdue. And, I'm sure that the STD bus was going to happen whether or not there was a collaborative effort with Mostek. So as I mentioned with these earlier cards with Prolog, this was not a bus backplane, meaning that the backplane was not in parallel to all of the individual cards. It was ad hoc, wired point to point. And that was, obviously much different than S100 or multibus. And, these had both demonstrated that a fully bused backplane was the way to go. And just being, the technical nightmare of everybody wiring their own back connection, it really only made sense for the STD bus to be a fully bused backplane where the bus is connected in parallel to all the cards. So in the cooperative effort with Mostek, Prolog was bringing to the table not only the physical standards of their product line, but they were bringing, years of experience that Mostek didn't have in board product development, marketing, and sales. And if you look at the pre-1978 line of Prolog boards, so things that were made before STD BUS was developed, it's obvious that even if it was, at least on paper, a collaborative effort with Mostek, the STD BUS was the clear evolutionary descendant of the 400 4000 and the 800 8000 series boards from Prolog. As I mentioned earlier, the collaboration began in the spring of '78, and things moved really quickly. I just don't think there was a lot of complicated technical decisions to be made. The basic premise was that the cards were going to have the same physical properties of Prolog's existing board products, so 4.5 by 6.5 inch cards, 56 fingers each side, or on both sides, 1/8 inch centers. But for the STD bus, the bus fingers were going to be reserved exclusively for bus use. So any external or board-to-board connectors were going to be on the opposite side of the card than the backplane. And as I said earlier, the backplane was going to be bused to all cards, so no more wire wrap individual or point-to-point wiring. The bus, with only one exception that we'll talk about a little later, is just connected from every card to the next card. So you can see in any of these backplanes, all of these connectors are just wired together. Just like a normal backplane like we think of today with either S100 or multibus or any of the other backplanes that we think about. As a nice touch, and to also match the previous boards, all of the STD cards were going to have this ejector up in the top left-hand corner to make them easier to remove. And other than the 5 volts, system voltage specifications needed to be loose enough to vary with the processor or memory or add-on cards. For example, you might have an analog card that required additional voltages. If it's an analog out, it might require plus and minus 10, even if you were using an 8085 that didn't require the negative voltages. But other cards, like this Analog Devices STD card, only needed 5 volts. It generated its analog output rails on board. So you can see it depended on really what you were putting into it, even things like what the voltage needed to be on the backplane. Just like power, there's a handful of signals that are loosely defined to provide for the flexibility of different processors. So for example, the Z80 puts out the refresh signal for the dynamic RAM, and the 8085 does not. So if you have a system based on the 8085, you probably don't have the refresh signal. But if you have a system that's based on the Z80, on the backplane, there's probably a refresh signal. And finally, the signal groups will be divided into 4 categories. There'd be the address and data with a 16-bit non-multiplexed address. So if you had a 8085, for example, you had to latch the address. 16-bit non-multiplexed address and 8-bit data. The next category were the memory and I/O. Think of things like the read and write lines. Then interrupt and bus control. Think, interrupt request, bus request, and their acknowledged signals. And finally, there was a bus master priority scheme that was built into the backplane. To me, the most curious part of the collaborative effort is the bus signals, which they were much closer to the Z80 than any of the Intel products. And that's interesting because, while the standard was devised by Prolog, Prolog's experience up until the STD bus was all Intel based. Intel had dominated the Prolog history and product line at that time. But in fact, versions of the 8085 S0 and S1 are about the only contribution to the 8085 that made it into the STD bus. The rest of the signals on the STD bus read pretty much just like the who's who of a Z80 datasheet. So back to the specification, they seem to have been settled, quite quickly. Within a year, by the end of 1979, there were 20 companies making STD cards, including two big ones. One was Analog Devices, made this very nice analog I/O card, and the other was Data Translation. So by 1980, there was no question that STD bus was going to catch on and be adopted. Now, Prolog branded their STD bus cards as the 7000 series. So while the 4004 and the 4040 were 4000 or 400, the 8000 was all, the 8-bit processors. The STD bus was going to be branded as the 7000 series. And, quickly this became their primary board line. The PLS 400, 800 series, as well as the related 4000 and 8000 series, would all be phased out and discontinued by Prolog in 1984. So after 1984, all of these boards were gone and everything was based on the STD. Let's look at the Mostek boards. Mostek branded their ST products as the Micro Design, or the MD series, which was a single board computer. And in fact, I think Mostek only made one MD Z80 single board computer product. The main focus was actually this MDX. So instead of the MD series, this was the MDX, where the X stood for expandable. So this was the Micro Design Expandable, or MDX, which was very kind of equivalent to the Prolog 7000 series. In 1979, Mostek had a dozen of these MDX boards, and they still only had that one MD-SBC Z80. So the MDX took over their product line. And in the 1979 Mostek catalog, STD boards were at the very front of their computer products, but that place of prominence for the STD bus wasn't going to last long at Mostek. There were some changes in the wind. While Prolog had that wide interest among the various processors and took the customer's always right approach, offered CPUs from all the manufacturers, Mostek was second sourcing the Z80 by then, so their interest was clearly in the sale of their own chip products, and certainly no interest in processors other than the Z80. So while the generic STD bus was being defined by Prolog, Mostek settled on their own variant, which they called the STD Z80. So STD bus and STD Z80 are not exactly the same. Formerly, the STD Z80 was a subset of the STD bus, but it was pretty obvious that Mostek's interest in STD was really just in pushing their own silicon. Plus, if you factor in that, the collaboration effort was in 78, Mostek merged with United Technologies in 1979, and then in 1980, they joined with Motorola and Signetics in developing the VMEBus. So other than using it to sell their silicon, Mostek was ready to move on from STD very early in the product cycle. So essentially, as soon as STD was defined, Mostek was all ready to move on to VME. As another thing, if you go back and look at a lot of the advertisements and literature, while most STD manufacturers were working overtime to ensure compatibility between different boards, Mostek was making a great effort to lock users into their hardware with wording like, be sure to specify STD Z80 bus, and including the disclaimer that on documentation that Mostek will not be responsible for any incompatibility of other manufacturers' STD bus hardware with Mostek's STD Z80 system. So Mostek was clearly defining a separation from their products from the other manufacturers. And these are just three of Mostek's cards. I think these might be the only, I might have another one, but these are basically the only Mostek cards I have. This is the MDX CPU2, so this is the Z80 board, single board computer. And then this is the MDX serial I/O and their MDX parallel I/O. As an interesting tidbit, STD BUS got a big boost in the April '79 issue of Electronics magazine, where I guess animators they're called, Chris Brown and Jeffrey Jeffries said that rather than using this handmade, wire-wrapped, TTL logic-driven, I think it's called the Dystraflex or whatever it was, that they used for camera control in the Star Wars animation, they were going to switch and use STD BUS to control the camera motion for the animation of the as yet unnamed sequel to Star Wars. So that alone, I think, probably raised awareness of STD BUS to people that hadn't heard it. And another of the big STD BUS operating system events, I'm not sure if they were the first to port it over, but in the fall of 1979, Microsys released CP/M for the STD BUS. So up to that point, most people were programming their own little either bare metal or some little operating system. But Microsys released CP/M. They sold their floppy drive controller and a 2-channel UART board along with CP/M as a $695 kit. And interestingly enough, Microsys is one of the few 1970s embedded systems companies that's still in existence today. I have one of these board sets, but I don't have any documentation for it. So I need to reverse engineer these boards one of these days. But until then, since they're still in business, I asked Microsys for documentation on these 40-year-old boards, but I'm pretty sure they're still having a good laugh at that request. Pretty soon, say by 1980, Prolog print ads were implying that they alone created the STD BUS, so their engineering designs should be trusted more than other manufacturers. And they emphasized that they didn't limit the customer's microprocessor choices, which was obviously a jab at Mostek. Or even more brutally, ads targeting Mostek like, do not limit your choice to a company that's pushing their own silicon. So back to Mostek by 81 or so. So now, we're 4 years after the bus was developed. Mostek seemed to be just coasting to the finish, while Prolog was aggressively marketing and expanding STD using taglines like, built by Prolog, the people who designed the STD bus concept. In 1982, there were at least 50 manufacturers building STD cards, and according to a Prolog interview in some trade journal, the STD bus industry was about 50 million annual, or 20% of the PC card market. So it was a big market. And that 50 million was obviously industry-wide STD card sales, not Prolog revenue. The next year, in 1983, the Mostek computer products catalog had VME in the place of prominence in the front chapters, but even though VME was the prime focus, the Mostek STD product line had grown to 20 or 30 MDX products. So they still saw value in using the STD bus as a means of pushing silicon. But there was a very big Mostek key event that took place in that time frame. So Jerry Winfield, who was the original designer of one of the first few Mostek STD boards, left Mostek in the early 80s, maybe 1982 or so, to start his own STD board company called Wintech. So, presumably Mostek was starting to lose interest in STD. So, Jerry Winfield left and started his own company called Wintech, which was later renamed to Win Systems. And they were up in the Dallas-Fort Worth area. And Win Systems, of course, became an absolute STD bus powerhouse. They left Mostek in its dust, and also, for that matter, they left Prolog in the dust. And since I was in Texas at the time, I was well aware of Win Systems. We switched to their products fairly early on. And I even have a T-shirt I saw the other day that they had sent with either, the purchase of some hardware or maybe at a trade show or something. Ultimately, Win Systems became and even remains one of the big players in embedded systems. And, there are always lots of great Win Systems hardware available. Now, as big of an impact as it must have been when Jerry Winfield left Mostek and started Win Systems, that pales in comparison to 1985 when United Technologies took a $425 million hit and posted a net loss of $45 million and just completely decided to shut down Mostek. So in 1985, Mostek went kaput, and so that was the end of their STD product line. One of the very nice systems from Win Systems is this card cage for STD. So this is really nice because It has a switching power supply where the Prolog ones at this time had linear power supplies. It's a nice card backplane, has a power button, has a reset switch, and these are very compact, very easy to use on your bench, very easy to get to. And so these are nice systems, and you'll see a lot of these available on eBay from Win Systems. While we're looking at card cages, this one is a little VersaLogic card cage. And then there's a lot of them from Prolog. This is a nice one. It has little handles on it for an 8 card. And then I've also got a little 16 card cage. Within another few years, in the mid to late 80s, the number of STD manufacturers had doubled again to at least 100 companies. And by 1990, STD had become an IEEE standard. It was the IEEE 961. And in the early 90s, there were 150 manufacturers of STD bus hardware. You could get an STD bus card for anything that you could think of. Now, after Prolog dropped the programmers as a core product line, they entered into a bit of a slump. And Ed Lee left as CEO in 1989, and Prolog would go on to be purchased by Motorola in 1997. And then ultimately the technology was purchased by Emerson. Somewhere along the way, the Prolog name and brand was ultimately dropped. And in 2004, the Prolog logo trademark was abandoned at the USPTO. And while they had abandoned the trademark in 2004, in the 2010 Emerson corporate documents, it was still listing Prolog Corporation as a name subsidiary. So I'm not exactly sure when Prolog eventually died. It shot up in 1970s, peaked in 1980, tailed, and then as you can see, it pretty much had died out by 2001. And, that's it. That's the end of a company brand. The brand is just gone. Poof. I should mention that there were a couple of extensions to the STD bus. I believe they were both kind of developed by Zeotech. The first was the STD 80. So you'll see STD, you'll see STD Z80, and you'll see STD 80, and those are all not exactly the same. The STD 80 was developed for the Intel 8088, and this is probably in the mid-80s. And then Zeotech went on, and with some others, they continued to whip this STD bus horse. They created STD 32 in the late 80s. And this is an STD 32 card. This one's from VersaLogic. And you can recognize it as an STD 32 by looking at the interleaved fingers on the card edge. So these new fingers are interleaved with the original STD bus contacts. So these two cards can actually be both inserted into the same backplane. This guy would obviously only connect to the original contacts, but this guy would connect to both of them. So you can plug this into a regular STD or an STD32 backplane. After the STD32, Prolog had the Pentium-based, the 7875 in 1993, and Win Systems had 586 and Pentium boards too. Zeotech would continue to be a player in STD bus arena until about 2000. When they finally dropped STD from their product line, but by then the manufacturer's guides show there were only about 20 manufacturers left in the STD pool. So by 2000, we were back to the same place we were in, by the end of 1978. But that's, a very good run. But the industry just needed better ways of handling more powerful embedded systems. Things started to diverge, and ultimately, new generations took over and the old ones die off. Not much different than people. So after STD, there was the run at STD 32, and then what? There was STD AT, but I never actually used it. We had switched to PC 104 at that point, or the PCI, which was another of the micro AT form factors. Zeotech came out with a compact PCI. I really didn't keep up with the industry and what it was doing after about 1995. So it's fantastic that people are interested in old hardware, and that's part of why I do these videos. I want to get the younger crowd to develop a desire to get a low-level understanding of hardware from the very dawn of microprocessors, which is what I consider to be vintage. But anything that can even remotely be associated with coveted machines like the MSI or the Altair or Sol or any of the Apple TRS, Pet Trinity for that matter, they're fetching absolutely insane prices. So if anyone ever needs a reason to look for an underappreciated vintage computer platform, this is it. And STD is a great target. The hardware is very low cost. It's very complete hardware. It's very well documented, and it's just readily available. For example, here's a listing for an 8085 single board computer. It went for $850 last month. That's $8.50 for a complete 1980s single board computer. Shipping was more than the card. This was probably from the mid 80s, judging from some of the markings on it, but that doesn't make it any less fun than, an 8085 single board computer from the mid 70s. And I think I have seen these this week or just very recently on eBay for, $8 or $9. And I think the guy had 7 of these that he was selling at $9 a piece. Here's a card cage for less than $20. This is the BX series, which came out a little later, maybe in the late 80s, but functionally it's equivalent to the one that I just showed a little while ago. So for $20, you could get a card cage. Here's a nice complete system with a Mostek Z80 MDX CPU, a serial I/O card, 4 RAM cards, a Mostek disk controller, 2 8-inch sugar drives in a cabinet, and a rack, a backplane power supply, and original documentation and software, all for $250. I mean, that is a nice little system. And these are just the ones I pulled off, the sold listings and sorted by price, but none of them are that unusual. A couple $100 buys a lot of STD hardware. Plus, it goes without mentioning that, it can be tricky trying to justify bringing home a $4,000 Altair, and it's much easier to bring home $20 STD bus cards that will completely slide in under the radar. Plus, who wants to risk their precious Altair when designing and building new hardware? While these small STD circuit boards, they're reasonably cheap to have made, and you aren't out that much if something goes south and catches fire on you. So, now I'm not knocking these systems and people that buy these systems for these prices. There's only so many Altairs, MSIs, and other dream machines floating around, and they're most likely going to serious collectors. In fact, there's a machine that I would consider paying this kind of money for if I ever found one. I just have never found it. But my point is there's an abundant supply of historically important hardware, readily available, educational. You can learn a tremendous amount. They're a lot of fun. It's not crazy expensive. And honestly, to me, it's much more fun to play with these STD systems and a little terminal emulator than it is to play with my Altair or my MSI or my Sol. In previous videos, I've pushed multibus as a low-cost entry point into historic vintage computing hardware, but if the physical size or the complexity of multibus is a bit scary, and if you don't want to build any of the modern kits with vintage processors like my SBC85 or the dozen other kits on 10D covering all of the 8 and 16-bit CPUs, then STD may just be something that you want to consider. It offers a wealth of learning opportunity. It's a great deal of fun. It's small. It takes minimal space. And it has a very low entry price. So to finish up, here's some examples of STD bus boards that I have. Some of them I use. Some just came with something else I wanted, and others I just rescued so they wouldn't go to the chip poachers or gold scavengers. Now, I have an affinity for Prolog just because I used them in graduate school, but there's many manufacturers to choose from, including Mostek and VersaLogic, and especially WinSystems. I would encourage you to look at WinSystems. If you don't have any particular brand loyalty, I think I would look at WinSystems because they offered one of the most complete families of STD cards. There's also, STD Prolog catalogs that are available. This is the 1981 product catalog, and this is, I think, is the 1983 catalog, 84. And before you jump onto eBay and possibly pay crazy prices, check out independent used booksellers online. They often have catalogs at a fraction of the eBay prices. And for most of these, you can just go to BitSavers and download catalogs and users manuals to learn about them. All Prolog STD cards are 7000 series, as I mentioned earlier, and they're grouped by hundreds. So the 7100s are all things like the backplanes. So if you look at a backplane in a system, this is a 7101 backplane. So that's the same backplane in the catalog right here. So all the 7100 items are support, like backplane. In this catalog, at least, in neither of these catalogs, are there any 7200 items. I'm not sure what those were going to be, but there aren't any 7200s. 7300s are peripheral interface. So this is a very nice one. This is the 7301. I'm sorry, this is the 7303 keyboard and display. And it's designed to go into the leftmost slot of the card cage. So it goes in here and you have a keyboard, you've got a couple of switches here and a little display. So this is a great card. If you come across them, that's a fun card. It's kind of a brute force interface. You know, there's not a keyboard controller on it, so it's a little brute force interface, but it's a really fun card to have in your system, you know, for lights and switches. So that's a 7303. 7304 dual UART card. I have around here somewhere the 7308 timer card. That's this one and these. You know, I've seen these on eBay for, you know, just several dollars also. So this has you know, like a 3-channel Intel timer counter on it. Then there's the 7314 that I've got. This is a 4-channel RS-232, and this has the Z-Log UART on it rather than the Intel UART that's on the 7304. This one is a case where I don't have the documentation for this card, but WinSystems and WinSystems and VersaLogic both made versions of this 7314 board, and you know, they got the same number, they got the same layout, so they have very close to the same features. They may be slightly different version, but I need to find the documentation for this. I have a short stack of these. I just haven't brought them up because I don't have the need for 4 serial ports. So the 7400s are analog I/O, and I don't have any Prolog analog I/Os. In fact, I think the only analog I/O that I've seen is in this catalog, and it's the thermocouple card, the 7401. That's the only 7400 card they've got. And honestly, others like Analog Devices made better analog cards than Prolog did. 7500s are industrial I/O. These are things like opto-isolators, higher voltage, higher drive currents, line voltage triacs. Here's a 7507 and a 7508, which they're actually TTL, but they're designed to connect to, you know, an Opto 22 or Gordos type I/O rack. The 7502 is for the shorter rack and has the edge connector, and then the 7508 has 48 pins of I/O. And these both have, you know, drive transistors here to power the rack, so you can remove power from the rack until the configuration is complete, or you can rapidly remove power if you need to do a shutdown or disable the rack. So these are 7500 industrial I/O. 7600 are digital I/O, and so these are, you know, I/O, but they're all TTL. So this is the 7604, and this is the 7601. So the difference is the 76, they both have 64 bits of TTL I/O. The 7601 was byte wide, and the 76 was more flexible, and it also had readback on it. But you can see you connect, you know, ribbon cables to each of these DIP sockets. So these were TTL I/O, so each of these had 64 bits of TTL I/O on them. Then the Prolog 7700s are memory. So this is the 7701. This is a 16K static RAM using the 2114. This is the 7702. This one had been modified to have ZIF sockets in it. The 7703, which I don't have, but this is the 7706, which is a 16K battery backed up RAM. This is the 7705. It's a 32K EEPROM board that uses the 2732s. And some of these higher numbers, like the 7705, started using the memory expansion line. So there is, on the bus backplane, there's an I/O expansion and a memory expansion. So you could use more than just the 256 I/O ports or 64K of RAM. And so some of these boards started using that memory expansion line. Then the 7800s are all of the processors. So let's get those out of the way. This is the 7801. So this is the 8085 single board computer. And then they followed that up with the 7805. So this is the 8085A. So this is the 8080, 8085A. They didn't make an 8080 in the 7000 series. So the Z80, the 6800, the 8085 were their base original processors on that. So these are both for the 8085 and the 8085A. This is the 7803, which was their first Z80 version, and the 7880, which was a follow-on Z80 version. So these are both Z80 and these are 8085. And as I mentioned, these will have different outputs on the bus. These will have the refresh, and these guys won't have the refresh, but they'll have the S0 and the S1. 7900s are support cards like extenders, prototype cards. They're all very useful, but I don't have any of them. 7901 is an extender card. We can look at those in the catalog if you ever find them. There's a 7901 extender. 7902 is a DIP prototyping card. 7903 is just a generic pad per hole prototyping card. And the 7904 is a really useful decoded I/O prototyping card. So all the 7900s are these just support cards that are all very useful. This is my extension card. It's a vector, I think, if I can get it out. Yeah, this is a vector, but it suits my purposes just fine. There's a lot of these extension cards that are really nice. They'll have test points for all of the bus signals and power and LEDs, and so you can get really fancy on the extension cards if you want. Now, in buying Prolog cards, you can kind of tell when they were made by some little features. So if you look at the very early ones, they will have Prolog spelled out, and they're in this deep blue solder mask. So, the earlier cards were the 4000 and 8000 series were this lighter blue. Some of the Prolog cards were lighter blue, and I'm sure it depended on what board house they were using. But the early ones tend to be in this deeper blue, or at least blue. And then they transitioned to just the Prolog logo, which they trademarked, and the green solder mask. So the blue solder mask went away, the green solder mask came. Let's see, this is the Intel Dual UART board I mentioned earlier, but I didn't show it to you. Then they changed the pour on the copper. So you can see these early ones are solid pours. These later pours, they went to the hatch design. So I'm not sure that you can see the pour on this is this hatch design rather than the solid pours. So they went from green with the solid pour to green with the hatch design. And then they changed to, it was hot item for a while. It was this more of a clear solder mask with the goldish or yellowish copper areas. And this one also, then they have the hatch design on the pours. Also, sometime about when the hatch design showed up, this openware mark started showing up. So you'll see on these boards, there's an openware and the little trademark sign. So it's not a registered trademark, it's just trademark. And in the 84 catalog, there's a couple of pages dedicated to the openware concept that started showing up on the boards. And I think that was about when this showed up. This would be in the 80, the boards that I have, if you look at the chip dates, it looked like maybe it started showing up in 82, 83, 84 kind of time frame. They have this openware on them. And while the Prolog logo or the PL logo was registered with the USPTO, this openware was never actually registered. So it never became a registered trademark. It just had a little TM by it. So it was an unregistered trademark. So I'm not sure whatever significance that is, but the openware did come up late, and then they made a big deal about the openware hardware. But you don't have to. As I mentioned, I focused on Prolog because I used it years ago. But with so many contributors to STD BUS, you can knock yourself out exploring other boards. Now somewhere I sat them down and I can't find them. Oh, here they are. This is the Microsys SB 8500 floppy disk controller and the SB 8040 dual UART serial board, which were part of their CPM package that I mentioned earlier. And this UART board is interesting. The spec sheet says that this socket is for a 256 byte PROM that's used as a bootloader. So basically you configured this socket with a PROM that would then become address 0, or it would boot off of that and load the code required for the disk controller to work. So that's going to be a good reverse engineering project someday to see how that was implemented. And as I mentioned earlier, they aren't parting with any documentation on these, so I think we're on our own. Maybe somebody out there has documentation for the Microsys dual UART board and the floppy drive controller board. That'd really be great. It's not on BitSavers or anywhere that I've seen it. A lot of other manufacturers. Here is a very handy. This is a Microlink 97114 EEPROM programmer. Microlink made a few other cards, but this is the only one that I have. It's a programmer. It's really nice, convenient. Has a configuration, little chip. So if you find one of these things, then you're able to buy it. You're going to want to make sure it's got that little configuration chip on it before you buy it. But this is a 21 volt programmer, so it can program 21 volt EEPROMs. So that's just a quick sampling of the most useful cards that I have for just mixing and matching and building little systems just for fun. As a final side note, I wasn't involved in the development of STD BUS. I was only an end user, or I was specifying control systems for embedded systems. So this is all from my recollection or what's publicly available in old books and catalogs and magazines and the internet, of course, and things that I have sitting around. But certainly any input or backstory from people that were involved in Mostek, or especially Prolog, or any other STD manufacturers, it'd be really, really interesting to hear from them. So if you were in that development industry at that time, from 78 to 83, and you were actually developing STD cards, it would really be interesting to see what it was like working in that consortium between Prolog and Mostek, and just what the industry was like as a developer, because as I mentioned, I was just a consumer at that time. Well, that's it for this video. Next time, we'll look into the STD BUS technical details, basically the signals. And as always, I appreciate comments, and it would be great if you could hit the subscribe. Until next time, if you come across some interesting STD hardware, don't be afraid to jump in and put together a system with some patience and good shopping. $100 can get you a chassis, a power supply, CPU, some I/O like a UART card or TTL I/O. And if you come across anything, but you just don't want to part with the cash, be sure to let me know the details. It might be something that I've been searching for years and years. Okay, well, that's it. I will talk to you later. Bye-bye.